Imagine you are building an AI agent. You want it to read your GitHub issues, check a database, search some files, and maybe send a message on Slack. Sound pretty straightforward until you actually try to build it. GitHub has its own API, Slack has another one, your database works completely differently, and your file system isn't even an API in the same way. So now your AI application has to understand all of these different systems. And here's the interesting part. This isn't really an AI problem. Software engineers have been dealing with this problem for decades. And one of the simplest way to understand it is with something you may have already seen in software design, the adapter pattern. Imagine I have a device with one kind of plug, but the wall expects a completely different socket. The device works, the wall works, they just don't have the same interface. So I put an adapter between them. Now neither side needs to change. The adapter handles the mismatch, and that's basically what the adapter pattern does in software. The client talks to the interface it understands, the adapter handles the ugly detail of taking to the system underneath. And this idea is going to help us understand MCP. Let's go back to our AI agent. Without a standard way of integrating things, you can end up something like this. And every integration needs its own logic, its own API handling, its own authentication, its own error handling, its own assumptions. Then you add another tool, and another, and another. Pretty soon your application isn't just an AI application anymore, it's a giant collection of integrations. And that's the problem MCP is trying to address. MCP is a protocol that standardizes how an AI application can interact with external capabilities. The important word here is standardize. Instead of every AI application inventing a different way to connect to every tool, you have a common protocol that clients and server can understand. At the high level, you can think it like this. The application uses an MCP client to communication with an MCP server, and that server exposes capabilities in a standardized way. Some of the core MCP primitives are tools, resource, and prompts. Tools are things the application can invoke, resource provide data or context, and prompts are reusable prompt templates exposed by a server. So instead of teaching your AI application a completely different integration model for every external system, you give those systems an MCP interface. Now let's put the two ideas side by side. And this is where I want to make an important distinction. MCP is not the adapter pattern. MCP is a protocol, adapter is a software design pattern. So I'm not saying MCP is literally an adapter. What I'm saying that they share a similar architectural ideas. Put a well-defined interface between the caller and the implementation. The MCP server handles the system-specific details. The AI application can interact with the MCP interface without implementing a completely separate protocol for every underlying system. That's the useful connection. And actually, I think this is the more important part. The real idea underneath all of this is loose coupling. Imagine your AI application directly depends on everything. Every new integration adds another dependency. Now put a boundary in the middle. Now the application doesn't need to contain custom integrations logic for every external services. Each MCP server can handle the details of its own system. That gives you a much cleaner boundary. And this is a very familiar software engineer idea. We do this everywhere. We use interfaces, we hide implementation detail, we separate responsibilities, we reduce coupling. MCP is applying those same architecture principles to the problem of connecting AI application with external capabilities. Let's make this concrete. Imagine I tell my coding assistant, find the open issues in my GitHub repository and send me a summary on Slack. Conceptually, the application might have access to two MCP servers. The application can use the GitHub MCP server to access the GitHub capabilities it needs. The results come back to the application, the model can then generate the summary, and the application can use the Slack MCP server to send that results. Notice, what's important here, MCP isn't magically connecting the models directly to GitHub. There is still software doing the work. The MCP server is responsible for the integration with the underlying system. MCP gives the client and server a standardized protocol for communicating. That distinction is important. Now imagine you are building an AI coding agent. Today you support GitHub, tomorrow you want GitLab, then Jira, then Notion, then your internal database. Without some kind of standard boundary, every new integration can become another custom piece of application code. With MCP, those capabilities can be exposed by different MCP servers, and the application can interact with them through the MCP model. That's where composability becomes interesting. You're not building one giant application that knows how every external service works. You're building an application that knows how to work with a standard protocol, and capabilities can be added behind the boundary. But there's one important thing I don't want you to take away from this video. MCP is much more than an adapter. It's a real protocol. MCP standardizes messages and interaction between clients and server. And its specification cover things like tools, resources, prompts, authorizations, transports, and other protocol behavior. MCP message use JSON RPC. and the protocol evolving pretty quickly. The July 28, 2026 specification made a major architectural change. MCP's protocol core became stateless, removing the old protocol level initializations, handshake, and MCP session ID. It also introduced things like multi-round trip request, header-based routing, cacheable list results, and authorization hardening. So the adapter pattern is useful here as a mental model, not as the definition of MCP. So if you remember one thing from this video, remember this. MCP isn't making AI magically understand every tool. It's solving a very familiar software engineering problem. How do I connect many different systems without tight coupling my application to every one of them? The answer is standardize the interface. Then you can reduce coupling, you can separate responsibilities, and you can make a new capabilities easier to plug in. That's why I think the easiest way to understand MCP isn't actually to start with AI. Start with software engineering because MCP is taking a very old engineering idea and applying it to a very new problem. If you like this video, do me a favor, please hit subscribe button. See you in the next one. Peace.